All right, let's go ahead and get started. You'll get 1 point extra credit for filling out the evaluation of the course and instructor. There is one possible problem here, is that it's anonymous. So I don't know who filled it out unless more than 5 of you fill it out. So I can't really give extra credit unless at least 5 of you fill it out. But do you know how to fill these out? Okay, you go on to Blackboard and then click SEI surveys. Yeah. Okay, but yeah, I really appreciate any comments, feedback, what I can improve, what you liked about the course, all that stuff. And that 1 point extra credit will go toward your final exam. So about the final exam, the goal is to ask one of the 2 or 3 most important questions. And I'm going to identify most important questions as being ones that you're most likely to see in the future. If you're going on to a different major, I don't know, whatever your major is. If it's business or, I don't know, what are your majors? Biology, all those kinds of things, right? There are 36 sections we covered in the book, but I can only ask about 20 questions or less. So I wanted to narrow down the search a little bit. So I've put a list of all the topics we covered in each section. It's a ton. So I've highlighted in yellow the ones that I'm going to pull from. Okay, because it's just so much. So I wanted to narrow down the search a little bit. Personally, I would start with 10.4 and work my way backwards because I'm less likely to pull questions from chapters 1 and 2 as I am to pull questions later on. So I'm just going to talk about how I'm going to make the final. My first question I'm going to make, I'll probably make it the last question on the test, but from 10.4, I'm going to ask one of these 2 questions for sure. One of these 2 questions for sure, that is, if I give you a 3x3 matrix, can you find the inverse? Or if I give you a system of 2 equations, 2 variables, can you solve it by finding the inverse and multiplying by the inverse? Okay, so that's 2 skills from this class. 2 separate skills, right? Can you do rule operations? And can you do matrix multiplication? So that's another thing I'm going to take into account when I'm making the test. That is, I'm for sure going to make you do a rule operation problem, but that can be from solving a system, or it can be from finding the inverse of a matrix. So I'm going to ask you one of those 2. Then I'm going to for sure ask you to do a matrix multiplication problem, and that can be either straight up, can you multiply these 2 matrices, or can you solve the system? So those are 2 important skills that you're going to want to master. All right, going up to 10.3. So multiply matrices or apply it to solve an equation, right? One of those 2 I'm going to ask. Adding, subtracting matrices. Also, I didn't ask that on the last test. I gave you one that you couldn't add, right? Because they didn't have the same dimensions. I'm likely to ask either maybe use matrix algebra to solve for the variable matrix. And I might have 2x minus 3a is equal to b. And then can you solve for x? And plug in given, if I give you a and b. Given a is equal to 1, 2, 3, 4, b is equal to 5, 6, 7, 8. That type of question. Okay, so I'm just going to go through these topics and then let me know if there's one that you want to study thoroughly. 10.2, do you know how to identify the solution set to dependent system, 3x3? 10.1, can you use Gaussian elimination or Gaussian elimination on a system of equations on a matrix? I'm going to ask one of these 2 for sure. 9.4, a nonlinear system. So we had one of those on the last test. We did the addition method for that. But I'll likely ask one of these. It's not for sure. I'm tempted to ask a modeling question for a system of equations. So can you come up with the equation of a plane passing through 3 ordered triples? Or just, this is the one I asked you on the third test. So one of these are likely, but maybe this is slightly more likely. Then ask it. Okay, for 9.1, I'm going to ask an application problem. I didn't put application on the last test. I'm going to ask either a mixture or a uniform motion word problem. So that's 2 variables, 2 unknowns, x and y. You solve that system. 4.6, on the last test, I gave you a literal equation with all these variables. I think I gave you a is equal to p times 1 plus r over n to nt. I asked you to solve for t. So since I already asked that on this test, I'm going to for sure ask the other, an exponential growth or decay problem. I'm skipping the logistic though. Okay, so for sure asking one of these 2 problems, solving a exponential equation or logarithmic equation. You guys did really well in the log equations, but they're pretty important. So I'd be leaning toward asking another log equation. Can you use the rules of logarithms to expand or compress a log? Can you graph a logarithmic function? Can you graph an exponential? Or interpret a given graph? Find the inverse of a function. There were only a handful of types of functions I asked you to find the inverse of. I'll ask a different one that was on the last test. I won't ask the same type. I think I gave you a rational equation on that one. So maybe a quadratic. Identify when a function is 1-to-1. Okay, I totally forgot to put this on the second test. So this will for sure be on the final exam. It's a word problem. Can you tell when things are directly or inversely proportional? They vary inversely or directly. And can you solve a word problem given that? Polynomial or rational inequalities or an application of it. So for sure one of these in the form of, I don't know, either 5x over x minus 3 less than 2. Can you solve this type of equation? This isn't a nice one, so I wouldn't solve this one in particular, but this type of inequality. This went very poorly on that test, so I'd highly recommend studying variations of that. Another example would be like find the domain of f of x equals the square root of x cubed plus 2x squared plus x. So this is an application of a polynomial inequality. How do you find the domain of a square root function? We say whatever's inside must be greater than or equal to 0. So this is a polynomial inequality. How do you solve these? By factoring and doing a sign chart. And then this was probably the most missed question on test 2. Was it test 2 or test 1? Test 2, yeah. This type. Yeah, for sure, a graphing a rational function or interpreting the graph, a rational function. Probably graph it. So can you identify horizontal, vertical asymptotes or slant asymptotes? And graph plot points and connect the dots. Maybe one from here, I'm not sure yet, but definitely should know these. You have to know them to graph it anyway, so for sure master that. Okay, I didn't ask you to do, I'm not sure if I did ask you to do one of these with complex non-real zeros. So that's a likely question. Can you do synthetic division with complex numbers? Yeah, so from these two, likely two questions will come from here. Sketch a polynomial function. Likely be one of the questions on the exam. And or the multiplicity or zeros given a graph. Or can you construct a polynomial given its graph and a point? And I'm talking about a non-zero point. So I'm not sure if I'm going to ask a question from here, but if I do, it'll be one of these two. So the application of quadratics is you're finding a maximum or minimum, so you just need to find the vertex. Use the vertex formula. Operations on functions or composition of functions. Can you perform those? And I'm omitting the difference quotient, which you did on the previous test. You'll see again if you go into calculus. Can you perform the operation and give the domain of the function? The symmetry, this question did not go well on the test, so I'm very likely to ask this again. I'll just say I'm going to ask this again. Determine if function's even or odd. What does that tell you about the symmetry? So a lot of memorization here. And then possibly one of these graphing a piecewise function. For sure, transformations of graphs will be on there. Point slope formula, it's really important going forward in future math classes or just straight lines come up a lot, but it's like a prerequisite skill, so I'm not sure if I'm going to put it on there. So as a possible functions and relations, can you determine the domain of a function? Can you tell when it is a function, when it's not? That'll be a question. I'll ask one question from one of these topics, either graphing a function you're not that familiar with by plugging in points, finding the intercepts of a function, or one of those questions about circles. So definitely want to memorize the equation of circle, how to find the radius, things like that. Yeah, this is a question that didn't go well, so I'm very likely to ask it again on the first test, compound inequalities and absolute value inequalities. I'm likely to ask either a quadratic equation or one that's quadratic in form. Sorry, a radical equation. So most likely one from here, unless I don't have room. I'm not sure if I'm going to ask you to solve a quadratic explicitly, but it comes up over and over again in the other questions. And I already said mixture and uniform motion, but I'll ask it in the system of equations section. So there's more practice here if you want, but I'm just going to ask one of those, likely from section 9.1. I don't think I'm going to have time for one of these, but this is a possibility, a rational equation with fractions. Okay, so any questions about the final exam? Okay, any topic that you want to go over? Practice. The word problems? Okay, so personally, the way I would study for this is I would first go through the notes, list out the things I need to memorize, the theorems and formulas, and then I would maybe try a problem in the notes. So you can look at the blank document notes and try them out. And then if I need more practice, for instance, this type of problem, I'm going to open the textbook. Where would this be? 9.1 practice exercises. I'll do a screenshot. Here's an example of 4 of these questions, and I'll paste this over here from section 9.1. 9.1 mixture problems. Okay, now I'm going to look for uniform motion. When you open your textbook, does it show you the answer? Does it? Okay. Wait, what did that do? Okay, so when I clicked on it, it showed me the solve solution. Does that not do that for you? Okay, so this play button, does that show you how to do it? Okay, so you can do a video for how to solve it, and then it'll show you the actual steps to solve it. Anyway, that being said, which type do you want to try? A mixture problem or uniform motion? Mixture, okay. Do you have preference? 51, 52, 53? 50 what? 53, okay. So a radiator has 16 liters of a 36% antifreeze solution. How much must be drained and replaced by pure antifreeze to bring the concentrate level up to 50%? So I'm going to draw a picture so we can interpret what's going on here. I'm going to set this as background. Okay. I have two things I'm mixing together. So I'm going to add these together to make some combined mixture. It tells me that I have 16 liters of a 36% solution. So I'm going to say this is 36% antifreeze. And I'm going to say that up to here is 16 liters. How much must be drained and replaced? So I'm going to drain it. And we don't know how much, so that's my unknown. How much must be drained and replaced? So drained and replaced with this thing that I'm mixing together, and this is pure antifreeze, or in other words, it's 100% antifreeze. So this will create a mixture, a combined mixture that is some unknown level, y, which would be this unknown level after I drain it, right? After I drain some unknown amount, I'm left with y plus some x amount here of pure antifreeze. So this is like pictorially what's going on, just so that we can interpret and understand it. But we have some amount of solution times the percent antifreeze equals the quantity of pure antifreeze. Okay, so we have, if you feel comfortable with the chart, you don't have to do it, but it does organize the data. So the first two rows will be what we're mixing together. I'm mixing together a 36% antifreeze solution with a 100% antifreeze solution to get some combined mixture. And that mixture, it tells us, is 50% antifreeze. Okay, any questions about this so far? So we'll go ahead and fill in the percentages as decimals. 0.36. What's 100 as a decimal? Yes, 1 and 50%, 0.5. Okay, so the hard part is filling in these variables, but based on our picture, we said the unknown amount we're draining and filling with antifreeze is X. This is the pure antifreeze solution. And then the amount of 36%, we don't really know. It started with 16 liters, but we drained an unknown amount. So we're left with Y remaining. So these are two unknown amounts, but we know that altogether there's 16 liters. If you drain it and replace it, you get back to 16. So this is our first equation. That is y plus x is equal to 16. And that should make sense that we're adding these two together to make the total from the original. Okay, any questions about this? So one of these columns are going to be given with all the numbers given. One of them will be variables, and then you multiply across. We multiply to get 0.36y, 1x, and 0.5 times 16, or 8. Okay, does anyone know what our other equation will be? Yes. So we're mixing those together, so the quantity of pure antifreeze will add together to make the total in the mixture. 0.36y plus x is equal to 0.5 times 16. So how do we solve this resulting system of equations? Do you want to do substitution or elimination? Elimination? Okay, so multiply this by -1. Or do you want to do matrices? -y minus x equal to -16. Actually, you know what? Let's keep it all positive and let's multiply this one by -1. And so that will give us 0.64y. The x's cancel. And we get 8. What's 8 divided by 0.64? What's that? It's 12.5? Okay. I'm going to double check. Not that I don't believe you. All right. So that means, well, what's the question asking for? How much must be drained and replaced? Okay, I found y, but it's really asking for x, the amount that should be drained and replaced. So then let's do y plus x is equal to 16. But let's go ahead and plug in 12.5 here. And so when we get x is equal to 3.5 liters of pure antifreeze. All right, any questions about this? All right, any other problems you'd like to practice? Yeah, with matrices, without matrices? Okay, so that is section 9.2. I don't know, do any of these look like fun to you? Or which one do you want to try? 19? Okay, 9.2. So if it just says solve, you can use any method you like, including not using those, not using matrices. So we're going to solve this without matrices. We want to find the order triple x, y, and z solution. And the way I think about this one, or the most efficient way to solve it, is I want to eliminate one variable. So I, for instance, could say, this already has y eliminated, so why don't I combine these two equations and eliminate the y? Then I'm almost done. So this is R1 and R2. I would say, how do I eliminate the y? R1 plus -2R2. So that would give me x plus 2y plus 4z is equal to 3. And the bottom one is -2y minus 6z is equal to -10. We add these together to get the y's cancel by design. X minus 2z is equal to -7. Okay, and so I'll call this equation or row 4. Okay, I'm going to point out a mistake that has been made on the test. It's that I need to make sure to combine all three equations. So I did have on the test someone combining equation 4 with the previous equation. But equation 4 already includes equation 1 and 2. So if I don't include equation 3, I'm actually going to get a dependent system when it's not dependent. So I need to make sure to use all of them. This is already using 1 and 2. I need to use 3 also. This one's not that interesting. Those are the same equation, huh? So R3 plus -R4. That would be x minus 2z is equal to -7. -x plus 2z is equal to +7. And these cancel to make 0 is equal to 0. So it's a dependent system. So we need to write the solution set. So we could just say, if we let z be itself, such that z is any real number, can we find x and y? I'll use the second equation to say y plus 3z is equal to 5, or subtract 3z from both sides. So we get y is equal to negative 3z plus 5. And then this was a mistake that occurred on the test also was finding x. So make sure to review the gradient of your test. X plus 2y plus 4z is equal to 3. We do need to plug this in for y here. So x plus 2 times negative 3z plus 5 plus 4z is equal to 3. And we want to get x by itself. So we'll distribute the 2. X minus 6z plus 10 plus 4z is equal to 3. We'll subtract 10 from both sides and add 2z to both sides. So x is equal to 2z minus 7. Are there any questions about this? Or did I make a mistake? I was going fast. Okay, any other types of problems you guys want to try? I have one. Are any of you guys on Twitter? This came across my feed. I was like, whoa, this is like a monster algebra problem. You want to try and solve it? It combines 3 or 4 skills from this class in one problem. Try it. Unless there's another problem you guys want to try. The first step's hard. So we do want to use ln eventually. What's the problem about using ln right now? Yeah, we have no way to simplify it if there's addition in the middle. I'm going to, hopefully, if I write it in this way, we can see what's going on here. Does that help at all? Power to power, you multiply them. So this is the same thing, right? In each of those. So you let u equal 7 to the x. Do you remember this? Yeah. So that looks a lot like u to the first power plus u squared plus u cubed is equal to 155. So that's substitution. We did that in chapter 1. Now this is what type of equation? It's a polynomial equation. Do you remember how we solve these? And you have to make one side 0. Remember how we find the solution set to this? This is a really important skill. So if I gave you this on a test, you should for sure be able to solve it. We just did use substitution. So we want to solve for u. We're finding the zeros of a polynomial. We can try factor by grouping, but it doesn't work. We have to do the rational zero theorem. Remember that? Yeah, this problem's monster, huh? What's the P and Q stuff? What are P values? Factors of 155, right? What are looks like it's divisible by 5. Is it? Let's do 155 first. 5 and, do you have a calculator? That's 65? 35? 31? Wow, way off. 31 that's prime, right? So thankfully there's not many options. And what are my factors of Q? 1. Okay, so my options are 155, 31, 5, 1, -1, -5, -31, -155. All divided by 1 and -1, right? Yep, synthetic division. So what do I do here? Okay, but what constants are right here? 1, 1, 1. Okay, what did you want to try first? 1. Okay, bring down the 1. Let me try it first. Okay, add it, multiply it, add it, multiply it. Yeah, it doesn't work. But I was hoping I get all positives. I don't. So I can only cross out the 1. Okay, what do you want to try? I heard 5. Is that what we said? 5. What's that? -5. So we bring down the 1, multiply it, add it, multiply it, add it. That's not it, right? Okay. What do you want to try next? I guess I could try cross out -5. Oh, wait, is it alternating?
Yeah, so you can.
It is alternating, right?
Yeah.
This would be negative. So I can cross out these also. Awesome. Just 3 more to try. What do you want to try next? Maybe +5? Bring down the 1, multiply it, add it, multiply it, add it, multiply it. Okay, so we got it. U minus 5 is a factor. So this corresponds to u squared plus 6u plus 31. Is it factorable? 1 and 31 is our only option, right?
Yeah.
So it's non-factorable. So we use another skill from this class. Yes, quadratic formula. U is equal to -b plus or minus square root of b squared minus 4 times a times c. So u is equal to -6 plus or minus. Does someone have a calculator? 36 minus, it's -38. Okay, which simplifies to square root of -4 times, or 8 times 11, so 4 times 22. Is that right? Yes. So -6 plus or minus 2i root 22. And we can write these each over 2. -3 plus or minus, and these 2's will cancel. Okay, so we have the solutions are u is equal to 5, u is equal to this +1, and u is equal to -3 minus I root 22. We solve for u, but we want to solve for x, right? So we back substitute. What's u equal to? 7 to the power of x. So what's the last step? Yep, now we do the natural log. Natural log of 7 to x equals natural log of 5. X natural log 7. Natural log 5. These ones are non-real, so we'll throw them out. Because what's the natural log of a complex number? We haven't talked about that. That's another class. Yeah. So you can make natural log into an imaginary function that takes imaginary numbers, but we haven't talked about that. We'd say non-real. And this is our answer. So we used 4 skills from this class, right? Okay.